Assalamualaikum. My name is Jiveria Zafar and I am the student of MS Chemistry from UMT. My presentation topic is technologies and some fundamental subatomic particles. This file is submitted to Dr. Hamad Majid. First of all, I will tell you about what are the contents of my presentation. Contents are nanotechnology. Then I will tell you about Pico technology, then Femto technology, and then some subatomic particles which I will discuss here. First of all, what is nanotechnology? Nanotechnology is a field of research and innovation concerned with building things, generally materials and devices on the scale of atoms and molecules. You can imagine whenever we want to build a building, we need bricks. Like that, some building things, generally some materials and devices at the scale of atoms and molecules, this is called nanotechnology. Actually, nanometer is 1 billionth of a meter. You can imagine hydrogen atom, but nanometer is 10 times smaller than the diameter of a hydrogen atoms. As you know, hydrogen atom is very small, but nanometer is 10 times more smaller than the hydrogen atom diameter. You people see the diameter of human hair. One human hair contains around about 80,000 nanometers on average. These are some examples which will clear the concepts of nanometer size. Number one nanometer is equal to almost 10 to the power minus 9 meters, which is round about 1 billionth of the meters. Second one, a human red blood cell is about 7,000 nanometer wide. These four pairs of molecules are less than 1 nanometer wide. A human hair is 50,000 to 1 lakh nanometer thick. Your fingernails grow about 1 nanometer per second. 1 nanometer is to a tennis ball what a tennis ball is comparatively to the earth. Just imagine one tennis ball according to our earth. How much difference in these size? These are the comparatively atoms according to the nanoatom. I hope your concept about nano size is cleared with these examples. Next, I will tell you about the brief history of nanotechnology, how nanotechnology begins. On December 29, 1959, physician Richard Feynman gave a radical lecture at an American Physical Society meeting at Caltech titled. He said that there is a plenty of rooms at the bottom. Feynman suggested that it should be possible to make machines at a nanoscale that arrange the atoms the way we want. As you people have concept that when computer is discovered, we required a room for placing this computer. Like Feynman said that, take this concept from this example. Feynman said that, can we synthesize machines at a nanoscale? It might be possible. This lecture was actually the birth of idea and study of nanotechnology. From this concept, scientists take nanotechnology concept. Nanotechnology is used in almost all fields, medicine, environment, household, industry, energy, information technology. Almost in every field, nanotechnology is used. I will discuss nanotechnology's application in some fields. Number one, applications of nanotechnology in food science and food microbiology. Actually, nanotechnology, nanostructured food ingredients are being developed with the claim that they offered improved taste, texture, and consistency. The rising consumer concerns about food quality and health benefits are impelling the researchers to find the way that can enhance food quality. whenever distributing least the nutrition value of the product. Actually, the demand of nanoparticle-based materials had been increased in the food industry as many of them contain essential elements and they also found to be non-toxic. They have also been found to be stable at high temperature and pressure. Nanotechnology offers complete food solutions from food manufacturing, processing to packaging. Nanomaterials bring almost about a great difference not only in the food quality and safety but also in health benefits that food delivers. Nanotechnology is used in almost all processes involving food sciences. Food security, protection against spoilage and pathogenic microbes, development of innovative products, food processing, nano additives, cleaning and sensors, improve production of food crops and advanced food packaging. And the second one application is nanotechnology used in medical. Nanotechnology is used in medicals in a variety of methods. One application of nanotechnology in medicine currently being developed involves employing nanoparticles to deliver drugs, heat, light, or other substances to specific types of cells, for example, cancerous cells. This technique reduces damage to healthy cells in the body and allows for earlier detection of diseases. Nanotechnology is used for the detection of any defective part, diagnosis, drug screening can also be occurred by this gene delivery from one cell to other can also be occurred by nanotechnology. So you can say nanotechnology is used at every field. Next is Pico technology. The term Pico technology is a combination of two words which are Pico and technology intend to parallel the term nanotechnology. If we compare Pico technology with nanotechnology, as we discussed, nanotechnology is 10 to the power minus 9 times and the Pico technology is 10 to the power minus 12. It is a hypothetical future level of technological manipulation of matter on the scale of trillions of a meter or picoscale. Picotechnology would involve the manipulation of matter at the atomic level. Picotechnology is used by some researchers in nanotechnology to refer to the fabrication of structure where atoms and devices are positioned with sub-nanometer. Picotechnology this Pico comparatively nanotechnology, Pico technology is the trillions of a meter in other way at pico scale. The size is 1/3 of nanometer and these orders of magnitude smaller than in the field of chemistry, transformations and measurements. Next. Pico technology's application. Pico technology is used by some researchers in nanotechnology to refer to the fabrication of structures where atoms and devices are positioned with sub-nanometer. Alternation of structure and chemical properties of individual atoms, typically through the manipulation of energy states of electron with an atom to produce metastable or otherwise stabilized states with unusual properties, producing some form of exotic atom. Less toxic method, which is a less toxic method that is used to improve tissue growth. Our next technology is femtotechnology. Actually, femtotechnology, you can say picotechnology is the future of the nanotechnology and femtotechnology is the future of picotechnology. Picotechnology and femtotechnology have no practical application, but they both are conventional. Femtotechnology is actually a hypothetical term used in reference to structuring of matter on the scale of a femtometer. which is round about 10 to raise by minus 15 meter. This is a very small scale in comparison with nanotechnology and also small than Pico technology. Nanotechnology is 10 to raise power minus 9 and Pico technology is 10 to raise power minus 12. But Femto technology is 10 to raise power minus 15 meter respectively or comparatively. Applications of Femto technology. As you know, there are many atoms and molecules which are made up of nucleons, which are located in the nucleus. But the electrons rotate in the orbits around nucleus at millions of times more distant than the diameter of nucleus. You can say, or you can just imagine a gigantic vacuum having vacuum space which is totally free, and just one nucleus, very small part of the available space is present. You can take this concept from this example, like if a cricket stadium in which is completely hollow, which is completely empty, and just one pea is placed in the center of the whole empty cricket stadium, then this empty cricket stadium is the empty space in the atoms, and the P which is located in the center of the stadium, this is a nucleus. So now you can clearly take concept how much space in nucleus is empty, and nucleus which is according to atom very small sized. This femtotechnology, the purpose of this femtotechnology is used to find the order of location of protons and neutrons. For this purpose, we use AB matter, connection of nucleus by using AB needles. In this AB matter, actually the purpose of AB matter is that we find the location of protons and neutrons. As we know, protons and neutrons both are present inside the nucleus. How they both are located in the nucleus, we find this from AB needles. These AB needles will tell the distance which is present between protons and neutrons. This is the femtotechnology. Now I will tell you about some subatomic particles. Subatomic particles, as you know, the fundamental particles are electrons, protons, and neutrons. Electron is negatively charged, proton is positively charged, and neutron is neutral in nature. We know about these three fundamental particles. Instead of these particles, there are many particles which we can't see from our naked eyes are discovered. These are called subatomic particles. Subatomic particles are particles that are smaller than atoms. You can say atom is made up from these subatomic particles. They are present within an atom and can't be seen from our naked eyes. We use different instruments for seeing these particles. Almost more than 100 subatomic particles are discovered. They are also called elementary particles because further we will make elements from these atomic and subatomic particles. These particles are collide at high energy. The collision energy becomes available for the creation of these subatomic particles. Number one, neutrino. Neutrino is a kind of elementary particle. Neutrino have no electric charge. That's why they can't be affected by electromagnetic forces. Electromagnetic forces can affect only those particles having charges. Either it is positive or either it is negative. These particles, which are neutrino, are much lighter than electrons. But these neutrino particles are electrically neutral because they have no charge. These neutrino particles abundantly found in nature. Our sun, stars, and atmosphere produce millions of neutrinos in every second. Can also be produced artificially. One more point, neutrino particles can also be produced from the radioactive decay process. Neutrino particles properties. Neutrino particles pass through our body and we didn't even realize. As I already tell you that they have no charge. They are neutral in nature. They have high penetrating power. They can penetrate through walls and it has much more penetrating power. That's why they can penetrate from the mountains. Even from the mountains, they can transfer momentum and energy to the object when they collide with them. Neutrino detection is very difficult because many other particles, when we want to detect the neutrino particles, other particles will reach to the detectors. So for the detection of neutrino particles, we have to place these particles inside the mountain because many other particles which can't be penetrated in the mountain. That's why it is a better method that for the detection of neutrino particles, we place it in the mountain. Sun neutrino. As previously I have tell you, neutrino can be produced from the sun. That's why that neutrino particles which are produced from the sun, they are called sun neutrino and they produce from the nuclear fusion reaction. Fusion reaction is that in which two small particles combine or fuse with one another and make a large particles. Initial reaction for the production of sun neutrino is for the production of the neutrino is the proton-proton reaction. Means when two protons collapse with one another or react with one another, then some neutrino particles are produced. Second one is quarks. Quarks are there are most subatomic particles which are made from quarks. For example, protons and neutrons, which we know proton is a positively charged and neutron is a neutral. These are the fundamental particles of our atom. Protons and neutrons are not truly elementary. They are actually the systems of truly bound quarks. Means some quarks combine and form protons and neutrons. Quarks are not found in isolation. Means quarks are not found in single form. Morgel and George Swig discovered these particles. Quarks are classified into 6 types. These types are classified into top quarks, bottom quarks, strange quarks, charm quarks, up quarks, and down quarks. Third one is leptons. Leptons don't interact with strong interaction. Means leptons can interact but not with strongly bound. Antiparticles are the antileptons, which are identical but carry opposite charges and lepton numbers. Means one is leptons and its anti is called antileptons. These both are identical but they have opposite charges and lepton numbers. In nature, 6 leptons particles exist. 3 charged leptons, which are called electron-like leptons, having negative charge, and other 3 are neutral, and they are called neutrinos. Next one is fermions and bosons. They are 2 fundamental classes of particles. They include quarks and leptons and some other composite particles. Means fermions and bosons composition is that different quarks and leptons and many other composite particles, they combine with each other and form fermions and bosons. Next is graviton. Graviton, as its name shows, these will mediate from the gravitational force. These are elementary particles that mediates the force of gravitational interaction. Next one is baryons and mesons. They are made from the quarks and anti-quark combination. Means when quarks and anti-quarks are combined with each other, then they form baryons and mesons. Here is the references. That's all about my presentation. Now you can ask about any questions. If there is any question in your mind, you can ask in comment box. As soon as possible, I will comment the answer of your question. Thank you.